Hello students, in this video we'll see how the transport equation can be solved by using the chain rule. Let's consider the problem of let's find a class of functions f of x, y that satisfy the transport equation. And this is a simplified version of the transport equation. We can do a more general version after we do the simple version. The transport equation for us will be fx, the x partial derivative, is equal to the y partial derivative. Typically, we think of one of these variables as time, and so time is the temporal variable and x is the spatial variable, and then we're transporting some data along the direction of the time axis. And so what we want to do for this, but of course the variables don't really matter so much. What we're going to do here is we're going to rewrite this in just a more simple form. It just says fx minus fy is equal to 0. Now what we're going to do is we're going to change the coordinates. And so what I'm going to do is the following. I'm going to introduce two variables. I'm going to let xc be x plus y, and I'm going to let eta be x minus y. And for those who have seen some linear algebra, you realize I'm basically just rotating the coordinates a little bit. This is a rotation of coordinates and a little bit of a scaling as well. So this is the change of coordinates I'm going to use. And so now let's write fx in terms of xc and eta and see what happens. So we're going to use the chain rule now. So by the chain rule, partial f partial x is partial f partial xc, partial xc partial x, plus partial f partial eta times partial eta partial x. So I'd like to find partial xc partial x and partial eta partial x. Thankfully, they're pretty easy to do. So what's partial xc partial x? Partial xc partial x is equal to 1. What's partial eta partial x? Partial eta partial x is also equal to 1. So partial f partial x is the same as partial f partial xc plus partial f partial eta. Beautiful. Let's do partial f partial y. So what will partial f partial y be? Partial f partial y is going to be partial f partial xc, partial xc partial y, plus partial f partial eta partial y. Again, we can find what partial xc partial y and partial eta partial y is relatively quickly. Partial xc partial y is what? Is 1. Partial eta partial y, the partial of eta with respect to y, is going to be negative 1. So this is going to be what? This is going to be partial f partial xc minus partial f partial eta. So now, let's look at our original transport equation. Our transport equation is partial f partial x minus partial f partial y is equal to 0. So let's write out what that will be. So that will tell me, so partial f partial x minus partial f partial y, if this is equal to 0, what is this in terms of the xc and eta? Well, this is going to be partial f partial xc plus partial f partial eta minus partial f partial xc minus partial f partial eta. And now if we simplify this, we see the partial f partial xc's will cancel out, and we'll just have 2 partial f partial eta, which says that partial f partial eta is 0. Partial f partial eta is equal to 0. So if you have a function of two variables, if you have a function of xc and eta, which f is by changing the coordinates, so if you have a function f, which depends on xc and depends on eta, and there's no relationship in the eta variable, so the change in eta is 0, that means this function f is a constant with respect to eta. So f is a constant with respect to what? F of xc and eta. If we do the integral of this, we integrate this, we get a constant with respect to xc, not with respect to eta, excuse me. So is a constant with respect to xc, or just a function of xc, because there's no eta dependent, so there can't be any etas over here. So f of xc and eta is just a function only of xc. Now what is xc? Xc is just x minus y. So xc is just x plus y, excuse me. So f of x y is just some constant function c which depends on xc, and c is just going to be x plus y. So the function f of xy is just some function of the variable x plus y. So any function of x plus y will solve this transport equation. We can see a quick example of that. So if I pick any function I like of x plus y, let's just pick this function over here. If I look at x plus y squared, that's a function of x plus y. What's the x derivative of this? The x derivative of this is 2x plus y. What's the y derivative of this? The y derivative of this is going to be 2x plus y. So the x derivative is equal to the y derivative. I encourage you to pick any other function of x plus y. Maybe you could choose this one, for example, sine of x plus y. So take some time and compute the x derivative of sine of x plus y and the y derivative of sine of x plus y. You see that the x derivative is the y derivative. So any function of just x plus y will solve this transport equation. Thank you very much.